Hello everyone. Welcome to our channel. In our previous videos, we explored the history of natural numbers, fractions, negative numbers, zero, rational numbers, and irrational numbers. Although real numbers may seem obvious today, it took thousands of years to construct them, piece by piece, idea by idea. Let's walk through that journey step by step. Natural numbers, together with the later discovery of zero, became the whole numbers. Adding negative whole numbers gave us the integers. Integers combined with fractions formed the rational numbers. And once irrational numbers were finally recognized and understood, all of these together created the real number system, one of the greatest achievements in mathematical history. Today, we will put together the historical development of both fractions and rational numbers, and summarize how all these concepts came together to form the real number system. Let's see how we built the real numbers. Here is the outline for this video. Natural numbers, where it all began. Rational numbers, fractions and ratios. Negative numbers, less than nothing. The discovery of zero, a revolution. Irrational numbers, the shocking discovery. Real numbers, completing the number line. Modern perspective, real numbers everywhere. Summary: how we built real numbers. Our story begins with the earliest tool that humans invented for mathematics, natural numbers. Civilizations used them for counting sheep, measuring grain, and tracking days. 1, 2, 3, 4, and so on. Simple, universal, but only the beginning. As societies grew, people needed more than whole units. They needed parts of a whole, to divide land, mix ingredients, and exchange goods. This need gave rise to fractions, later called rational numbers. A rational number is any number that can be written as a over b, where a and b are integers and b is not equal to 0. Rational numbers include fractions such as 1 over 2, 3 over 4, minus 5 over 7. Terminating decimals, for example, 0.25. And repeating decimals such as 0.333. Repeating forever. Civilizations such as the Egyptians used unit fractions, like 1 over 2, 1 over 3, 1 over 4, while Greek mathematicians studied ratios extensively. By the Middle Ages and Renaissance, rational numbers became fully established as the set of all possible ratios of integers. Rational numbers were powerful, but still incomplete. Negative numbers originally caused confusion and were rejected by many Greek mathematicians. How can you have less than nothing? They asked. European mathematicians avoided them. But Chinese mathematicians used negative numbers centuries earlier for trading and bookkeeping. Eventually, negative numbers proved essential for solving algebraic equations, giving birth to the next big family of integers, such as -3, -2, -1, 0, 1, 2, 3, and so on. The next breakthrough was the invention of zero, one of the most revolutionary concepts that have been discovered ever. It emerged as a placeholder in Mesopotamia, but was first understood as a real number by Indian mathematicians like Brahmagupta. With zero, natural numbers expanded into the family of the whole numbers 0, 1, 2, 3, and so on. Around 500 BC, the Pythagoreans believed that all numbers were ratios of integers. Then came a bombshell: the diagonal of a unit square is a square root of 2, and cannot be written as a fraction. This was the first known irrational number, and legend says Hippasus was drowned at sea for revealing it. Famous irrational numbers include the square root of 2, the constant pi, the constant e, the golden ratio phi. Irrationals filled the gaps between rational numbers. Over the centuries, mathematicians found ways to unify natural numbers, whole numbers, integers, rational numbers. irrational numbers. In the 19th century, mathematicians like Dedekind, Cantor, and Cauchy provided a formal, rigorous foundation. They used ideas like Dedekind cuts, sequences approaching limits, set theory. Together, these created the real number system, a continuous, complete number line. Today, real numbers are essential in all fields such as calculus, physics, engineering, computer graphics, economics, data science, everyday measurement. The real numbers are the backbone of nearly all modern mathematics. Let's recap the evolution of real numbers. Natural numbers, counting. Rational numbers, fractions and ratios. Negative numbers, debts and direction. Zero, the idea of nothing. Irrational numbers, non-rational quantities. Real numbers, a complete number line. Each discovery was surprising, controversial, and transformative. Thanks for watching. Next, we shall talk the history of the complex number system. If you enjoyed this journey through the history of real numbers, don't forget to like, subscribe, and hit the notification bell. Let me know in the comments what mathematical idea you'd like to explore next. See you in the next video.